Ever clicked a paint bucket and watched color spread perfectly through a region? That's flood fill, a pattern mastery 100 staple that tests if you can control recursion/iteration, guard edge cases, and traverse grids cleanly. Interviewers love it because one tiny bug creates infinite loops. Today, we'll nail it with basics so your solution is fast and bulletproof. Let's break it down. We're given an image grid, a starting cell, SR, SC, and a new color. We must recolor all four directionally connected cells that share the starting cell's original color. If the original color equals new color, nothing changes, return the image. Now let's assess it. This is a classic graph traversal on a grid. Use DFS or BFS. Watch two pitfalls. If new color equals old color, early return to avoid infinite revisits. Stay inbounds and only traverse cells with the old color. Complexity is middle.n time, middle.n space worst case, stack/q, for an m times n grid. Here's the structure. Plan with BFS, iterative and interview friendly. Read old equals image SRSC. If old equals new color, return. Push SR, SC, into a queue and recolor it immediately. While queue not empty, pop R, C, for each neighbor, near, NC, in 4 durs. If inbounds and image near NC, equals old, recolor and in queue. Line highlighted, old _ color equals image SRSC. We grab the original color at the starting pixel. This tells us what region needs filling. Line highlighted, if old _ color equals color. If the pixel is already the target color, we skip everything and return the image. Line highlighted, m equals len image, n equals len image 0. These store the number of rows and columns so we can check bounds easily. Line highlighted, directions equals 1, 0, 1, 0, 0, 1, 0, -1. This defines the 4 directions, up, down, left, right. We'll explore. Line highlighted, q equals SR, SC. We start our BFS queue with the starting cell. Line highlighted, image SRSC, equals color. The starting pixel is recolored immediately as the first change. Line highlighted, while Q, we process cells until no more connected pixels of the old color remain. Line highlighted, I, J equals Q.pop 0. Take the next pixel from the queue to explore its neighbors. Line highlighted, for DX, die in directions. We try each of the 4 directions from the current pixel. Line highlighted, if 0 less than equals ni, less than m and 0 less than equals nj less than n and image ni nj, equals old _ color, only valid and same colored neighbors qualify for recoloring. Line highlighted, image ni nj, equals color, we recolor the neighboring pixel. Line highlighted, q.append ni, nj, and add it to the queue so its neighbors can be checked as well. Line highlighted, return image. Finally, we return the fully flood-filled image. Highlight input box, image equals 1, 1, 1, 1, 1, 0, 1, 0, 1, SR equals 1, SC equals 1, color equals 2. Here, we start flood fill at position 1, which currently has the value 1. Our job is to recolor this pixel, and any connected pixels with the same value, to 2. Explain briefly. The pixel at 1, 1 connects to a whole block of ones around it. Up, down, left, and right. All of these connected ones get changed to 2. Pixels that are diagonal or blocked by a different number, like the zeros, are untouched. Highlight output box, 2, 2, 2, 2, 2, 0, 2, 0, 1, and that's exactly the result. All connected ones were replaced with 2, matching the expected output. So the flood fill works correctly, spreading outward from 1, 1, and recoloring only the valid connected region. Line highlighted, class solution. We define a solution class to hold our method. Pause. Line highlighted, def flood fill self, image, SR, SC, color. This function performs a flood fill, changing connected cells of the same color to a new color. Pause. Line highlighted, old _ color equals image SRSC. We grab the starting pixel's original color. Pause. Line highlighted, if old _ color equals color, return image. If the starting pixel is already the target color, we don't need to change anything. Pause. Line highlighted, m equals len image, n equals len image 0. We store the number of rows, m, and columns, n, for boundary checking. Pause. Line highlighted, def DFS I, J. We define a DFS helper to explore all valid connected cells. Pause. Line highlighted, if I less than 0 or I greater than equals m or j less than 0 or j greater than equals n or image ij equals old underscore color. If the cell is out of bounds or not the original color, we stop exploring. Pause. Line highlighted, image ij equals color. We paint the current cell with the new color. Pause. Line highlighted, DFSI plus 1, j, DFSI 1, j, DFSI, j plus 1, DFSI, j1. We recursively fill neighbors in all 4 directions. Time complexity, OM middle.n in the worst case, since we may visit all cells. Pause. Line highlighted DFSSR, SC. We start the flood fill from the given starting pixel. Pause. Line highlighted, return image. We return the updated image. Pause. Final wrap-up. And that's how this algorithm works. It first checks for unnecessary work, then uses DFS to recolor all connected cells matching the original color. Efficient, simple, and elegant. Highlight input box. Image equals 1, 1, 1, 1, 1, 0, 1, 0, 1. SR equals 1. SC equals 1. Color equals 2. Here, we start flood fill at position 1, which currently has the value 1. Our job is to recolor this pixel, and any connected pixels with the same value, to 2. Explain briefly. The pixel at 1, 1 connects to a whole block of ones around it. Up, down, left, and right. All of these connected ones get changed to 2. Pixels that are diagonal or blocked by a different number, like the zeros, are untouched. Highlight output box, 2, 2, 2, 2, 2, 0, 2, 0, 1, and that's exactly the result. All connected ones were replaced with 2, matching the expected output. So the flood fill works correctly, spreading outward from 1, 1, and recoloring only the valid connected region. Ever clicked a paint bucket and watched color spread instantly across a region? That's flood fill, a perfect test of clean grid traversal, recursion control, and edge handling. Let's do a recap. We're given an image grid, a start cell, and a new color. The task: recolor all connected cells, up, down, left, right, that share the starting color. If the starting color already matches the new one, we simply return the image as is. It's a classic graph traversal disguised as painting. We can use BFS or DFS, both work. The main pitfalls? Avoid infinite recursion when the color doesn't change, and stay inside bounds at all times. The plan: record the starting color. If it's already the new color, stop early. Use a Q, BFS, to recolor the start cell and expand to 4 directional neighbors with the same color. Continue until no connected cells remain. We executed this BFS plan, handled edge checks, recolored properly, and ran it on LeetCode with 0 errors. All test cases passed. Traversal and recoloring behaved exactly as expected. The big lesson: flood fill isn't just about color, it's about control. Managing boundaries and revisits cleanly proves you understand traversal flow from start to finish.